All right, some nested lists happening for you here in our key concepts area. With the integral calculus that we've most recently been covering, we started off with rules for applying integrations to functions manually. And we've talked about the indefinite type as well as the definite types of integrals. Up next, we're going to go over a quick code demo to show you how you could calculate integrals in Python. So I wanted you to understand how to do integrals by hand, and I do have some comprehension exercises coming up. But of course, in a lot of scenarios, we after understanding the theory, we want to be able to scale things up and apply things automatically with code. All right, from github.com/johncrone/mlfoundations, we return to our notebooks directory, and we even return to our subject 4, Calculus 2 notebook, potentially long forgotten by you, but we were working with this notebook a lot earlier in these live lessons. So make your way down to the bottom of the notebook for a segment on integrals. And in here, our only dependency is the quad method from the SciPy integrate module. And quad stands here for quadrature, which is a type of numerical integration. So numerical integration is analogous to the automatic differentiation that we were using to calculate derivatives with PyTorch. It's the integration analog. All right, so let's say we want to solve the definite integral. So that integral was y equals half x, or x over 2, same function. So in integral notation, definite integral notation, we have our function x over 2. We're saying what variable we would like to integrate over, which is x. And we're using our integral symbol to indicate the range that we would like to integrate over, which is over x equals 1 through to x equals 2. Now, in the slides, we already determined that this was going to come out to 3/4 units squared. But now we can also do the same thing in Python. So first, let's define a function. Let's call that function g, which performs this operation, x divided by 2. And now we can use the quad method to calculate our definite integral. So we pass in as arguments the function, the start and the end of the range, and boop, out pops 3/4. In case you're wondering, the second output here of the quad method is an estimate of the absolute error of the integral, which in this case is essentially 0. It's 8.3 times 10 to the negative 15. Effectively, there is no error. Nice, that was easy, right? So now you know how to calculate integrals by hand, as well as calculate definite integrals in Python.